Hello guys, welcome back to another video. So I didn't specify a lot of things. I said stuff in a blurry way, you can say it like that. So in this video I just want to simply explain stuff because I just didn't really give enough proof in my opinion. Like no I did, but in a blurry way. So I just want to explain stuff even clearer. So okay, let's get into the video. So first, in this situation, in the KOBI theorem, if these sides aren't tangent to this circle, tangent means that it this line, this line, this line, this line only intersects this circle in one point. So if these sides aren't tangent to this circle, and if they are not parallel to each other, so if these tangent lines aren't parallel to each other, then this KOBI theorem won't work. These tangent lines should form a square outside the circle, and they should be tangent to the circle as well. So now I drew this. This is basically a radius touching this tangent line in the intersection between the tangent line and the circle. So in this point, and when a radius touches the tangent line and the intersection of the tangent line and the circle, the radius and the tangent line form a 90-degree angle. And it's same with these, 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 these circumstances. Now I want to look at these small squares. These are squares because every angle in these small rectangles, we can call it that for now, are 90 degrees. This is 9 degrees because the radius is touching the tangent line in the intersection. Same with this radius and this tangent line or this side. These tangent lines are perpendicular to each other in this situation, and we know that this whole thing is a square, so this is also going to be 90 degrees. And we know that sum of all angles is 360 degrees, so this angle will equal to 360 sum of all angles minus this angle, and this angle, which are 90 degrees. So this will also be 90 degrees. We know this side is equal to this side, therefore the opposite sides in this rectangle will equal to R and R. So we have just realized now that these small sides are equal to radiuses, these radiuses. And we see here that this whole side equals to r plus r, so this side is going to be equal to 2r, and we know that 2r, 2 times the radius, equals the diameter. And this is relevant in all circles. This is same with all sides. So these four sides will equal to 2 times r, or the diameter. Okay, we know from last example that these sides equal to 2r, so this 2r and this is 2r. We'll have to find the diagonal, and we're just gonna come back to this. Now this is a really simple equation. We're just basically using Pythagorean theorem. So this is 2r, this is 2r, this is gonna be 2r squared plus 2r squared in the square root. So we can simply use these equations to find AC diagonal is equal to square root of 8 times r. In this conclusion, we see that QQ1 is a diameter, OQ is a radius because it comes from the point O, which is the center of the circle, so OQ is a radius, and OQ1 is also a radius because it comes from the same center, so it comes from this, and this is radius as well. QQ1 is the sum of radiuses, which is 2r, but we can't simply say that it can be a diameter. Well, if this OQ1 is slightly bent down like this or this, it won't be a diameter, it'll just be 2 radiuses. But we know that QQ1 are a part of AC line, which is a straight line. The diagonal in the square is a straight line. QQ1 is a part of this diagonal. It goes through O point, the Q point goes through the circle right here, and Q1 point goes through the circle right here. We can simply say now that QQ1 is a diameter because it's a straight line, it's made out of 2 radiuses, and it goes through the center. And now if you look at this tiny square, We know from the last equation, I'm talking about this one, where every small side, this, is the radiuses. And we're talking about this small square. I'm talking about this one. So AJOL. AO is the size of the radius. O is the size of the radius as well. And they form a 90-degree angle here because obviously AJOL is a square. We could just simply use the Pythagorean theorem again to find AO. AO squared would have been this side squared plus this side squared, which is r squared plus r squared. This would be 2r squared, and AO would simply be square root of 2 times r. We could have also found this using the division of square roots, but I already used that in the last video, so this is the easier version. Now we know what AO is, so we can just find AQ, the thing we're trying to solve for, which is B. AQ is equal to this half of the diagonal minus this radius, AO minus OQ. OQ is a radius. We can see this in here. OQ equals OQ1 equals R. So AQ equals AO minus OQ. This is the same as square root of 2 times R minus R. And this is the same as square root of 2 minus 1 times R, because the R comes out of these parentheses. And this equals to this because square root of 2 times R minus 1 times R. This is the same as square root of 2 times R minus R. R times 1 is the same as 1. Thank you guys so much for listening. I really enjoyed making the video.